Hello students, myself Tejaswini, lecturer in EMC, SJ Government Polytechnic, Bangalore. Today we are in the last session of this chapter Unit 1, that is Introduction and Architecture of PLC. Okay, and before starting our session, we will have a small recap on the previous sessions. Okay, so first we have learned what is PLC and what is the definition of the PLC. Definition in each and every session I am repeating. Okay. The definition of PLC in simple terms, it is a programmable device which is used to control the industrial automation or industrial environment. Then we have seen why we need PLC. Then what are the leading brands of PLC. Then what are the applications of PLC. Almost everywhere we are using the PLC. Next, we have seen how the classification of PLCs are made. We have divided into two types, that is modular PLC and compact PLC. In the modular PLC, there will be a extension of the modules. It will permit to add the units, that is IO unit, memory unit, etc. It is these in the modular PLC, all the components are independent to each other. Okay, we are connecting manually all the components and we are making the PLC system. If any fault or error occurs also, to replace and to repair, it is very easy in case of modular PLC. Next one is compact PLC. In compact PLC, all the components are embedded on a single case. There, everything is decided by the manufacturer. Understood? That is why it is called as compact PLC. Next, after that, we have seen the relay logic control and what is PLC logic control. In the relay logic control, it will have elaborate wiring for the components and it was very clumsy and everything was very difficult there to reprogram it. You have to go to the factory floor and you have to change the design of the circuit. But in case of PLC, everything sitting in front of the system, you can design the program, you can alter the program, you can check the output, everything. No need to go to the floor. So that is why we are having so many advantages of PLCs over relays. So today all industries they have shifted from relays to the PLC. Okay. This programmable concept it first developed in 1968. Who is the father of the PLC? Number of times I have told you. The father of the PLC is Dick Morley. Okay. And after that, we have seen the advantages and disadvantages of the PLC. In the advantages, to list some, the first one is flexibility, documentation, pilot running, implementing and correcting the errors, and then speed of operation and security. Okay, then we are having different types of programming methods in the PLC. We can choose whichever we want, but the most commonly used programming languages are ladder diagram and functional block diagram. Understood? These are some of the advantages of the PLC. And if we list some disadvantages of the PLC, we are having fixed program applications, that it is not efficient to use for a single application, the PLC. Then fail-safe operation, newer technology, environmental considerations, etc. If we see the advantages and disadvantages, the advantages of the PLCs are more compared to your disadvantages. Understood? And after that, we have seen the major components of the PLC. What are the major components of the PLCs? First one is your central processing unit. In that we are having microprocessor, memory, and then power supply unit. Understood? Then we are having IO modules, programming devices, then we are having racks and chassis. These are the most important components of your PLCs. Okay. After that, we have seen the working of the PLC. How it is working will happen in the PLC. It executes in a scan cycle. What is scan cycle? We'll be having some three steps in the working. First one is it will read or sense the input, then it will execute the logic, Then what it does, it will write or update to the output. This is called the scan time. So one cycle, it is called as a scan time. It will be measured in terms of milliseconds and it will be continuously happening in the PLC. So it is called as scan cycle. After that, we have seen the difference between the data processing computers and process control computers. Data processing computers are your normal PCs, that is your personal computers. Okay. And the keyboards and the inputs and outputs are same. The inputs are your keyboards and outputs will be your VDPs, etc. But in the process control computers, there also it of course it will process the data. Apart from that, it will also control the operations. Understood? So there the inputs will be switches and sensors, and the outputs will be your solenoids, motors, lamps, etc. Apart from the normal inputs and outputs. Here PLC is a process control computer. Then we have seen the I/O modules. Classification of I/O modules, that is your analog I/O module, then your digital I/O module. Okay. And then after that we have seen some basic concepts for the I/O module. That is, what is bridge rectifier? What is bridge rectifier? For AC to DC, if you want to convert, the conversion from AC to DC, it is called as your bridge rectifier. And what is optocoupler? Optocoupler we are using for to give the electric isolation between your input module and CPU and output module. Then we have triac output. Okay, we are using the triac output at the output module side. Understood? Then we have seen the input module system layout and the output module system layout. Okay. And next we have seen the different memory. What are the different types of memory we have seen? Understood? The memory, why we are using the memory? If you want to store the data or whatever you write the programs in terms of ladder diagrams, you need the memory to store it. Understood? And then we have seen the different types of memory. That is your ROM and RAM. In the RAM, you are having read-write memory as well as read-only memory. In the read-write memory, we are having SRAM and DRAM. That is static RAM and dynamic RAM. In the RAM, we are having PROM, EEPROM, EEPROM and flash RAM, flash memory. Understood? So we have seen these many topics in the previous sessions. Now, in today's session, we will see how the memory is organized in PLC, that is your programmable logic controller. Understood? First, memory organization in PLC. All PLCs contain both RAM and ROM in varying amounts depending upon the design of the PLC. Okay. The use of PLC's memory is determined again by the design of the unit. Based on the application or design of your unit, the use of the PLC memory is determined. However, all PLC memories can be divided into at least 5 major areas. It is divided into 5 areas. If you see the diagram here, we are having execute memory, that is of ROM, and system memory, that is RAM, I/O status memory, RAM, data memory, then it is RAM, user memory is of RAM, EEPROM and EEPROM. These are the 5 different areas of the memory. Now we will see one by one in detail. The first one is executive memory. Executive memory, or it is also called as operating system memory for the PLC. It should be always your ROM, that is read-only memory. ROM is a permanent memory. We cannot do any changes in the ROM. Understood? It is the one that actually does the scanning in the PLC. Okay. The operating system is a special machine language program that runs the PLC. Understood? It instructs the microprocessor to read each user instruction. It helps the microprocessor to interpret user program symbols and instruction, and also it will keep track of all the input and output status. It is also responsible for maintaining and monitoring the current status of the health of the system and all its components. The executive memory is nothing but your operating system memory. It is always of ROM. Okay. The second memory we are having is the system memory. What is system memory? In order for the operating system to function, that is your executive memory, a section of memory is allotted for system administration. For system administration, we are having some form of memory that is called as system memory. As the executive program performs its duties, it often requires a place to store intermediate results and information. So whatever the executive memory will perform, all those results are stored in the system memory. Normally, this area, the system memory, it is allotted for operating system only. It is not for user programming. Some PLCs use this area for storing the information which passes between the programmer and the operating system. The system memory is for operating system. Understood? Remember that. Next, IO status memory, that is your input or output status memory. In the previous sessions, I have already explained you whenever uh, in the system, always the inputs are monitored. Understood? So whenever it senses the input, that input variables, it will be stored in the RAM. Understood? That is a random access memory. Again, it is divided into two sections. One is input image file and another one is output image file. Okay. So in the input image file, what it does, the CPU, it will fetches the input variables from your input image file. Okay. Then what it does, according to the program, what you have written, okay, from the through programming device in your system, it will program according to that. And it will, the output image file, it will be filled by the CPU according to your program. Then it will actuate the outputs. Understood? This is the procedure. So the location within the input and output image tables are identified by addresses. Each location, it will be having its own unique addresses for the input image file as well as the output image file. During the execution of user program, the microprocessor, it scans the user program and interprets the user commands. So the status of input modules used, so whatever the variables will be there that are fed from your input image file. Various output device status generated during the execution of the user program are stored in your output image table. Understood? So this is for your inputs and output status. And next we are having data memory. So data memory, whenever your timers, counters, mathematics and process parameters are required, an area of memory must be set aside for data storage. So some manufacturers, they subdivide this data memory into two sub-memories. One is your fixed data memory and the other one is your variable data memory. Here the fixed data portion, it can only programmed via programming device, that is a 3C system. The CPU is not permitted to place data values in this area. Next one is your variable data. The variable portion of the data memory is available to the CPU for data storing. The fifth memory is user program memory. It is this memory area that executive program instruct the microprocessor to examine or scan to find the user instructions. The user program area may be subdivided if the CPU allocates a portion of this memory area for the storage of ASCII messages, subroutine programs, or other special programming functions or routines. Okay. In the majority PLCs, the internal data storage and user program areas are located in RAM. Several systems do offer an option that places both user program and a fixed data storage areas in EEPROM type memory. So these are the 5 different types of memory that are in the PLCs. Okay. And memory map, it is also how it is organized. Generally, in PLCs, the memory is divided into two. One, it is user memory, and the another one is the data memory. User memory means where the programmer, he will write the program, that is using the ladder logic program. It contains a ladder logic program, and always the user memory will occupy the more portion of the memory, that is more than 75%. The another memory is the data storage memory. In the data storage memory, it stores the information needed to carry out user program like the status of the discrete input and output devices, numerical values, sequential patterns, and etc. That is for data storage memory. And this is the memory map of your PLC. See, if you see the diagram here, so these are all the bit addresses. This bit addresses, they are in octal in number. See, here you can see 0, 0, 1, 2, 3, 4, 5, 6, 7. After 7, it is 10. So this they are written in terms of octal number system. And if you see here, this is the user memory part, and this is the data memory part. Okay. User memory part, it will be always more. As I told you, it will be more than 75%. And these are all the addresses. Okay. See here, you can see here 1110 to 117 is your input image status, 120 to 127 output image, 130 to 157 it is timer, this is counter, and this is numerical data. And see, let us consider the data storage memory. See, this is the data storage memory part. Here, input image status area. Input image status area. This is your input image status area. This is the having address from 110 to 117. This is also in terms of octal only. So here it is here that the status of discrete real world inputs are stored. That is, whenever the input module it senses the input signals, those are stored in terms of input image files in the RAM. Understood? Next one is output image status. Here it is between 120 to 127. So this is where the binary data, it will activate the real world outputs are stored. So once the CPU fetches the input variables from the input image file, then it will process according to your program. Then the output is stored in the output image file. It will process according to that. So that is the output image status area. Next is your timer status. In the timer status, it will be having your accumulated values and some preset values for the timer. This uses 24 watts. And next one is counter status. It will also be having the accumulated values and the preset values. It will also uses total of 24 watts. Then after that, numerical data. Numerical data, this is for number system conversion from 220 to 227 address. Understood? So this is about the memory, that is memory organization of PLC. So we are having 5 different types of memory here. Understood? Now let us solve some multiple choice questions. First one, the operating system or executive memory of the PLC is, I already told you, I have explained you, the executive memory, it is of RAM, ROM, PROM, EPROM. That is ROM, read only memory. Next one. In PLC, the greater portion is occupied by user memory. Is it true or false? Yes, of course, it is true. More than 75% it is occupied by the user memory. Next, the address in the memory map is represented in dash system. I have told you the addresses from the bits also, and then the addresses also 120 to 127, 110 to 117. It is represented in octal system. Okay. The PLC memories can be subdivided into dash major areas. In all the PLCs, the memory, it is divided into 5 major areas. The user memory, it contains dash, dash and dash memory, that is RAM, EEPROM and EEPROM. Okay. So this is the session on the organization of PLC. I hope you understood the topic. This completes the Unit 1 chapter, that is Introduction and Architecture of PLC. Okay. Thank you for listening. Bye.